Okay, in this video, we're going to go over the review for 7.3. So you'll be given the double angle formulas and a copy of the unit circle to answer the review. So let's get started. So look at these first questions. It says working backwards using the double angle formula. So a couple of things. You want to look at the expression they give you, and then your goal is to come up here to the formulas, and you want to identify whether it's this, or any of these. So you're looking for the left-hand side. So whatever you have for alpha, you're going to say times 2, and that's what it's going to be. So, for example, this first one, here is my alpha. It is 125. This expression matches with this right here. So this really, in a prior life, was sine of 2 times the 125, which equals sine of 250. Now I look at my unit circle, and 250 is not a unit circle angle, so I am done. This is my final answer with this first problem. Okay, look at the next one. The next one is 1 minus sine squared 80 degrees, so that looks like 1 minus sine squared 80 degrees. It looks like this. So here is my alpha, and therefore previously this could be written as the cosine of 2 times alpha, or cosine of 160. Also not a unit circle angle, so we are done at this point. Moving on, this clearly has to be the tan because we only have one tan formula, and this is it. This is your alpha, so this equals tan of 2 times 145, which is tan of 290, also not a unit circle value or angle, so we're done at that point. Okay, this next one is equivalent to the cosine of 2 alpha. This is your alpha, so it's going to be 2 times 6 pi over 13, which is the cosine of 12 pi over 13, and not on the unit circle, so we are done. Next one. Looking at E, this is the alpha. This is also cosine of 2 times that alpha. The 2 can cancel into the 12, making that a 6. This is cosine pi over 6, which is a unit circle angle. So you've got to come up to your unit circle. Here's where pi over 6 is. Cosine is the first value, and that's why it's radical 3 over 2. So this is radical 3 over 2, and that is your final answer. So I'm going to star the ones that are unit circle just so you know how I got a different answer than just the double angle formula. Okay, next one, sine next to cosine with a 2 in front. That was the sine of 2 times 75, because 75 was your alpha. So that is sine of 150, also a unit circle angle. So we come up and we figure out what 150 is. It's right there. In that quadrant, I know sine is positive. I'm going to put down a positive right there. And that all comes from all students take calculus. Okay, so I had gotten the 150. I see the reference angle is going to be pi over 6. I'm looking for sine. Sine is the second value, so that's going to be positive 1/2. Always put the sign down so that you know you evaluated it. Okay, moving now to G. This was cosine of 2 times 60, which is cosine of 120, also a unit circle angle. We come up. Here's 120. It's in the second quadrant. I'm looking for cosine of 120. Only sine is positive, so right away I'm going to put down a negative. Come back up. 120. Match the denominator of the radian measurement of 2 pi over 3. So therefore your reference angle is over here at pi over 3. and I want cosine, which is the first value, and that's why I'm picking 1/2. So this is negative 1/2. Okay, next one, 2 cosine squared 135 minus 1. That is going to be cosine 2 times 135, and that is the cosine of 270 degrees, also a unit circle angle. It's a quadrantal angle, so here it is at 270, and I need cosine, and cosine is the first value, so I'm going to get a 0 for an answer, and that is my final answer. So let's go back, and I'm going to store all the problems that took me over to the unit circle so that you see how I did that. Okay, and I'm going to fix this really quickly. I didn't want to cross it out, so that was going to be, what, 0, and that's my other answer. So let me highlight my little answers so you can see them, and then we'll move on to the next problems. Okay, so solving double angle problems in the coordinate plane. So that's your tip-off. You're going to be drawing a triangle. In this section, we only have to draw one triangle, so I'm looking at what they gave me as information, and they're telling me it's in quadrant 3. So start drawing the quadrants. You definitely want to draw your quadrant, okay? Don't just like be doing this in your head. That's a bad idea. So quadrant 3 is here. You put your pencil in the center, you go straight out, and then you go vertically up to the closest x-axis and put your right angle there, and that means your angle A. Okay, so I'm going to put my letter A right here, and the sine of A is negative 8 over 17, so that's opposite over hypotenuse. This is negative because I'm opposite the negative y-axis, and this is a triple, so I know this is 15, and it's also negative. Okay, so you want to know those things really well. All right, so now we have to find sine 2a and cosine 2a. So sine 2a, I would look up at the formulas. I have them somewhat memorized, but I'll go back up and show you exactly where we're going, right here. So I'm going to write in that. So I need 2 sine A cosine A, and right underneath it, I'm going to be filling it in. So don't forget to bring down the 2. Okay, the sine of A is opposite over hypotenuse, so that's negative 8 over 17, and the cosine of A is going to be negative 15 over 17, and you're going to multiply those together, and when you do that, you should be getting a positive 240 over 289, and that's your final answer. Okay, so that's what sine of A equals. So then we have to do the other one, which is going to be cosine of 2A. Now you have many different formulas you can do for that. So let's just quickly look up and see what we have. You have all of these. They are all cosine formulas. I tend to use the first one. So I'm going to use the first one. You can use any of the 3. You'll get the exact same answer. So the first one tells me that I'm going to have cosine squared of A minus minus sine squared of A. Okay, so cosine squared of A. Well, I knew cosine of A was negative 15 over 17, so I'm going to square that and get a positive. Minus the sine of A, just reading from my other problem, was negative 8 over 17, and I'm going to square that. So I'm squaring the values and not the angles. Okay, so when I get that all said and done, I'm going to end up with, let's see, so this is going to be 225 over 289 minus and 8 squared, negative 8 squared is 64 over 289, which ultimately gives me 161 over 289. And that is my final answer. Okay, moving on to question 3. Question 3 tells us if tan of A is negative 2/3 and angle A is in quadrant 2, find these other two values. So let's get going on that. So here's my grid. And I know I'm in quadrant 2, so I'm going to draw it right out of here. And here's my right angle. Here's my A. I'm going to now put my values on. I have a 2, I have a -3, and this I know I can solve it using Pythagorean theorem, which is here, and I will get a radical 13. So it's a radical 13 right there. Okay, so now we're going to do sine of 2a. Sine of 2a only has one possible equation, and it's 2 sine a cosine a. So I bring down the 2. I look and see that sine a is 2 over radical 13, and cosine of a is -3 over radical 13. I multiply those three terms together, and I get a value of -12 over plain old 13. So that's what sine of 2a equals. So let's highlight that since that's our final answer. And we can move on to the next problem, the next half of this problem, I should say. So I'm going to look for cosine of 2a. I already told you that I prefer to use the cosine squared a minus sine squared a form of the formula. And cosine squared a, I'm just going to read it off the side on my left here. That's -3 over radical 13. I'm going to square that. And then sine was the first value I identified from the triangle. And that's that. I'm going to square that. So I end up with 9 over 13 minus 4 over 13, which gives me a value of 5 over 13 for the cosine of 2a. So we've got a couple more of these to do. So looking at this next one, I am seeing that they don't tell me a quadrant. Well, they don't tell me it explicitly. So I'm going to show you how you're going to figure this out. So I draw little mini quadrants over here. It says tan A. What's important at this point is that tan is negative. So where is tan negative? Tan is negative here and here. Okay? Then they tell me that cosine of A is less than 0. That means cosine of A is negative. Well, cosine of A is negative here and here. And so which quadrant wins? The one with the 2 stars. So this is in quadrant 2. And that's how I figured it out. Okay, so draw your quadrant. Now your quadrant 2. Here comes your shape, your triangle, and your A goes here. Now we're back to what we've done before. We need to put our values on it. Given what I see here for tan, I know tan is opposite over adjacent. It's the adjacent that's going to get the -3, and this will be a 5 because it's a triple. Okay, so let's find sine of 2a. So sine of 2a is going to equal 2 sine a cosine a. Bring down the 2. The sine a value for this is 4/5. So I have 4/5 right there. And the cosine a value is -3/5. So when I multiply those three terms together, I get -24 over 25. And we are done. Now move into finding what cosine 2a is. So cosine 2a equals cosine squared a minus sine squared a, and other formulas as well work. So I'm going to take my -3/5 and square it, and take my 4/5 and square it, and I end up getting, after I do all my subtractions rather, -7 over 25. Done. Okay, we have 2 more of these to do. Here again, they didn't give us the quadrant, so I'm going to do my little method. Over here, I put my little quadrant symbol, and cosine is positive. So taking that as positive, I know it's positive here and here. And it says sine is less than 0, so sine is negative. And where is sine negative? Sine is negative here and here. And so quadrant 4 is the winner. So I'm going to draw my quadrant 4 triangle. So here comes out of here, here, and here. And here's where the alpha goes. And I'm going to label it so I know that cosine is 8 over root 73. So this is where the 8 goes. This is root 73. I do my c squared equals a squared plus b squared. And I get a 3 here. And because it's opposite the y-axis, that's negative, it's going to be a negative 3. Okay, so let's see if we can get these two. So sine 2a equals sine squared, equals, lost my head there, equals 2 sine a cosine a, bring down the 2. Sine a is negative 3 over radical 73. That's good. Cosine a is 8 over radical 73. And that ends up being a negative 48 over 73. Okay, so that one's done. Let's do the next one. So cosine 2a, that's going to be cosine squared a minus sine squared a. And when I do this, I am going to pull this down as 8 over radical 73 squared minus a negative 3 over radical 73 squared. So that's going to give me 64 over 73 minus 9 over 73, which gives me 55 over 73. And now we're done with that too. Okay, so one last one here. Once again, they didn't tell you the quadrants. We're going to do our little grid. And tan is going to be positive, so tan's positive here and here. Cosine is going to be positive also, because that's what greater than 0 means. Cosine's positive here and here. So quadrant 1 is the winner. Draw your triangle in quadrant 1. Okay, so here it comes. And it's an alpha. So tan is opposite over adjacent. And you're going to have to do your c squared equals a squared plus b squared. And you'll find that this is radical 61. And now we're ready to go. Everything's positive because I'm in that first quadrant. Cosine A. And then just plug in underneath it. So sine A is going to end up being 5 over radical 61. Cosine A is 6 over radical 61. Multiply those three terms together, and you get 60 over 61. Okay, last one of this type. So we have cosine 2a. I'm going to do cosine squared a minus sine squared a. Take your cosine, 6 over radical 61, and square it. Take your sine, 5 over radical 61, and square it. And when you do this math, this is 36 over 61 minus 25 over 61. You should be getting 11 over 61. All right, so now we have some easy things to do. We put these on because we found that you're forgetting how to deal with the unit circle. So let me go through that with you. Cosine of 210. First thing I do, I go up. Find the 210 in the unit circle. 210 is right here. That's it. The third quadrant. The third quadrant, I know that cosine is negative. So far I'm going to have a negative. 7 pi over 6 has a reference angle of pi over 6. Cosine is the is the first value. So I have my negative from the quadrant and the root 3 over 2. So let me write that down over here. So this is going to be negative from the quadrant and then root 3 over 2. Okay, tan of 210. Do the same thing. Come up here. Okay, 210 is right over here. exactly where it was a second ago. And that's going to be positive for tan. So far I know it's positive. And then your fraction is going to be sine over cosine. So it's going to be 1/2 divided by root 3 over 2. After you do that a million times, you realize that you end up getting numerator over numerator. So it's going to be 1 over root 3. And I know it's going to be positive. So I have positive 1 over root 3, which you have to rationalize. So that's why I'm getting root 3 over 3. Okay, next one, sine of 150. Come back up. Okay, 150 is right over here. So here's 150. Sine in this quadrant is positive, so now it's going to be a positive value first. Go over to your reference angle of pi over 6, and sine is the second value, so it's positive 1/2. So right here, we have positive for the quadrant, 1/2 for the value. Okay, sine of 270, that's a quadrantal angle. You come down here, sine is the second value. Oops, sorry, it's going to be a -1. So come back, -1. Tan of 90. Okay, you come up here to the 90, and you want tan, and tan, I'll write down, tan equals sine over cosine. Whoops, I don't know why this is erasing. Okay, so sine over cosine, and so that's going to be 1 over 0. 1 over 0 is undefined because you cannot divide by 0. So we call that undefined. Okay, a couple of more. Cosine 330. Where is that quadrant? That's in the fourth quadrant. So the fourth quadrant, cosine is positive. So now let's get the value. Cosine 330 is right here. That's a pi over 6. Cosine's the first value, so it's root 3 over 2. So, okay, tan of 120. So let's see where it is in the second quadrant. Tan of 120 will be negative. So first I need to put a negative there. Then I'm going to do 2 pi over 3. The reference angle is pi over 3. That's going to be root 3 over 1, grabbing both of the numerators. And so this is going to be a negative for the quadrant. And then it's just root 3 over 1, which you could have written just as root 3. Sine of 180 is quadrantal. So you can look at that. You'll get a 0. Tan of 135. That is in the second quadrant, so it's negative. And the value, the reference angle is going to be pi over 4, which is root 2 over 2, comma, root 2 over 2. That is same over same. And if you have same over same, that's a 1. Tan of 315, that's in the fourth quadrant. That's why it's negative. But you've got the same reference angle, so it's also 1. Okay, then you had some very quick algebra to do. So you've got to know that you can't add these together unless they have the same exact denominator. So that's our first job. So that's going to be 12x over 28 plus 63x over 28. And you can combine those together and get 75x over 28. Done. So you want to know how to do this algebra. Okay, here's your double-decker fraction. So what I'm going to do is I'm going to write it horizontally. This is 3/5 divided by 9/10. And then we say keep it, change it, flip it. I'm going to now reduce. 3 goes into itself 1 time. 3 goes into 9 3 times. 5 goes into itself 1 time. 5 goes into 10 2 times. Multiply straight across. And you will get 2/3. Okay, another double-decker fraction similar to tan equations, right? So the first thing you're going to do is multiply on the top, 12 over 12, so I can get the same denominators, 5 over 5. Okay, so that leads me to 36 over 60 plus 20 over 60. So I'm dealing with the numerator, and that's going to be what, 56, I'll write that better, 56 over 60. Okay, now let's work on the denominator. That's going to end up being 1 minus, you can multiply these together without getting the same denominator, 12 over 60. Okay, turn your 1 into 60 over 60 because that's equivalent to a 1 and that lets you do the subtraction. That becomes 48 over 60. When the denominators are the same, you can just use the numerators as your fraction and then say to yourself, okay, this can be reduced. So 8 goes into 56 7 times, 8 goes into 48 6 times, and you get 7/6, and we are done. So you definitely want to know how to work with these fractions. Seek help if you didn't understand that. Okay, that completes this video. I hope this helped you to understand double angle formulas and to recall how to work with the unit circle.